We want to now look at policy and shocks in goods market model. And here policy would be in our standard goods market model that we're looking at changes in T bar or in G bar, and shocks could be like changes in firms or consumers' confidence, i.e. changes in I bar or C. So let's start by analyzing the effects of changes in government expenditure on equilibrium output using the goods market model. So let's assume the initial equilibrium is at A at the intersection of our demand schedule is Z, C plus I plus J and a 45-degree line. Then what happens is we have an increase in G by delta G. Now that will shift the demand schedule upwards by delta G. It's going to be a parallel shift because demand increases for any given level of I by delta G. And we already know that any changes in any autonomous spending components cause parallel shifts in a demand schedule. So then now the new equilibrium is at A prime at the intersection of the 45-degree line and the new demand schedule is Z C plus I plus G prime. So as you can see, at the new equilibrium, Y increases from Y star to Y double star. Now let's note something. Let's look at the vertical axis. We already talked about this before that we can represent equilibrium output on the vertical axis as well, right? Because we already discussed this here. Let's go back again. We already discussed this, here. In equilibrium, demand which is on vertical axis is equal to output which is on horizontal axis. So in equilibrium, if Y is Y star, then Z is also Y star. So we can represent equilibrium Y on the vertical axis also. So we discussed this before. So if we look at the vertical axis, we can represent equilibrium output on the vertical axis also. So this Y star that we saw on the horizontal axis, I just plotted it on the vertical axis here. Because in equilibrium, if Y in equilibrium, demand which is on vertical axis is equal to output which is on horizontal axis. So if Y is Y star in equilibrium, then Z is also Y star. So I can represent this Y star on the vertical axis as well. Similarly, if Y is Y double star in the new equilibrium, then Z is equal to Y double star in the new equilibrium. So we can represent equilibrium output on the vertical axis, which we have done over here essentially. Right, so I've represented Y star here and Y double star here. So now, if we look at the vertical axis, the distance between Y star and Y double star is larger than delta G, right? So this distance delta Y star is actually greater than delta G. So the increase in output, which is Y double star minus Y star, which we can measure either on the vertical axis or the horizontal axis like over here, is larger than the initial increase in government spending. Now, this is due to what we call the multiplier effect. The term multiplier comes from the fact that it multiplies up any initial increase or decrease in aggregate demand, right? So we can see the effect on equilibrium Y is greater than the effect on G. This is due to the multiplier effect. Now the question arises, where does the multiplier effect come from? Which we'll look at in a later video.